Hello everyone, myself Professor Sudke SS of SND COE and Research Center Evla, working as Assistant Professor at Electrical Department. Today we will discuss the subject of Advanced Microcontroller and Embedded System, in which we discuss the Unit 3 that is CCP module and its applications. In this we discuss the topic of timers required for CCP applications in detail. First of all, we see the topic that is timers required for CCP applications. The CCP module is software programmable to operate in one of three modes. These are: one is a capture input, second is a compare output, third is a pulse width modulation PWM output. These are the three timers which are required for the operation of the CCP module. For the CCP module to function, timer resources must be used in conjunction with the CCP module. The desired CCP mode of operation determines which timer resources are required. For the CCP module to function, timer must be used in combination with CCP module. In each CCP module, the capture, compare and PWM modes use different timer resources. Then the timer's resources required by them are: the central part of this module's circuit contains a 16-bit CCP R1 register which consists of the modes of CCP module are selected using the bits of CCP con register, that is CCP control register, which is shown below. Its lowest bits are 0, 1, 2, 3. CCP X M3 as to CCP X M0 are used for selection of CCP mode, which is explained further in process of capture and compare modes. Then applications of CCP mode are: for the generation of square wave using compare mode. For the generation of the square wave using the compare mode in the CCP module includes the operations like accelerometers typically vary the duty cycle of a square wave in proportion to the acceleration acting on a system. By configuring the CCP module in capture mode, the PIC-R microcontroller can measure the duty cycle of the accelerometer with little intervention on the part of the microcontroller firmware. Then in this topic we discuss some question and answer about the square wave generation by using the CCP module of the compare mode. First is, what is the duty cycle of square wave? The square wave is a special case of a pulse wave which allows arbitrary durations at minimum and maximum amplitudes. The ratio of the high period to the total period of a pulse wave is called the duty cycle. That is, the duty cycle is nothing but the ratio of on time period divided by total time period of the particular cycle of the waveform. A true square wave has a 50% duty cycle, which is equal high and low periods. Then the next point is that square wave generation using CCP module. A square wave is a non-sinusoidal periodic waveform in which the amplitude alternates at a steady frequency between fixed minimum and maximum values, with the same duration at minimum and maximum. In an ideal square wave, the transitions between minimum and maximum are instantaneous. The square wave is a special case of a pulse wave which allows arbitrary durations at minimum and maximum amplitudes. The ratio of the high period to the total period of a pulse wave is called the duty cycle. A true square wave has a 50% duty cycle, that is equal high and low periods in the square waveform fashion. Then the square waves are often encountered in electronics and signal processing, particularly digital electronics and digital signal processing. Its schematic or stochastic counterpart is a two-state trajectory. Then the origin and uses of square wave generation in CCP mode. The square waves are universally encountered in digital switching circuits and are naturally generated by binary two-level logic devices. Square waves are typically generated by metal oxide semiconductor field effect transistor, that is MOSFET devices, due to their rapid on-off electronic switching behavior, in contrast to bipolar junction transistors, that is BJTs, which slowly generate signals more closely resembling sine waves rather than square waves. The square waves are used as timing references or clock signals because their fast transitions are suitable for triggering synchronous logic circuits at precisely determined intervals. However, as the frequency domain graph shows, square waves contain a wide range of harmonics. This can generate electromagnetic radiation or pulses of current that interfere with other nearby circuits, causing noise or errors. Then, in musical terms, they are often described as sounding hollow and are therefore used as the basis for wind instrument sounds created using subtractive synthesis. Additionally, the distortion effect used an electric guitar clips the outermost regions of the waveform, causing it to increasingly resemble a square wave as more distortion is applied. Simple two-level Rademacher functions are square waves. This is the example of the square wave which is generated by the compare mode of the CCP module. To avoid this problem in very sensitive circuits such as precision analog to digital converters, sine waves are used instead of square waves as timing references. Then the characteristics of imperfect square waves. These are, as already mentioned, an ideal square wave has instantaneous transitions between the high and low levels. In practice, this is never achieved because of physical limitations of the system that generates the waveform. The times taken for the signal to rise from the low level to the high level and back again are called the rise time and the fall time respectively. If the system is overdamped, then the waveform may never actually reach the theoretical high and low levels, and if the system is underdamped, it will oscillate about the high and low levels before settling down. In these cases, the rise and fall times are measured between specified intermediate levels such as 5% and 95% or 10% and 90%. Then the bandwidth of a system is related to the transition times of the waveform. There are formulas allowing one to be determined approximately from the other. Thank you.